In this video, we will learn about indirect measurements. You can use similar triangles to estimate heights and distances that are difficult to measure directly. For example, if an object is outside, you can use its shadow to estimate its height. The diagram on the next slide will show you how the angle between the height of the object and the length of the shadow can create a triangle. To find the height of the clock tower, you can measure the lengths of other shorter objects and both shadows and use similar triangles. The information is shown on the picture. We're going to fill in the measurements that are shown here. The height of our stick is 3 meters. The length of the stick shadow is 1.5 meters. And the length of the clock tower shadow is 8 meters. So the idea here is that the shadow is easy to measure because it's flat along the ground. These dotted lines are showing the angle at which the sun is hitting both of these objects, which creates the shadow on the ground. This has to be done at the same time of day so that the sun is hitting both objects at the same angle. If you've ever noticed your shadow, you know that at different times of the day, sometimes your shadow is longer or shorter than your actual height, depending on the angle at which the sun is above you in the sky. So this is the idea here of how we create that triangle, is it's at what angle the sun is hitting these objects in the sky. And so we can use the length of the shadow and the length and the height of a shorter object that we can more easily measure to find the height of something that's tall that we can't directly measure. So that would be the clock tower. You can answer these questions several different ways. You can use a proportion, you can use a unit rate, you can compare the height of the clock tower to its own shadow, or you can compare the height of the clock tower to the height of the stick. A few options, and I'll show you a couple different ways so that you can pick which way works best for you. So let's say option 1 would be to compare using a proportion. And you might look at this as x being the height of the clock tower to 3 being the height of the stick, and then 8 being the length of the clock tower shadow, and 1.5 being the length of the stick shadow. Another proportion that would work would be if you did x, the height of the clock tower, over 8, the length of the clock tower shadow, and then 3 over 1.5. So you can kind of look at these one of two ways, x to 3 and 8 to 1.5, or you could say x to 8 and 3 to 1.5. It's the same idea, just kind of a different order of comparison. Another option is by saying how many times longer is the clock tower shadow than the stick shadow. So how many times longer is 8 than 1.5? So that would be 8 divided by 1.5, which is 5.3 repeating. What that means is that the height of the clock tower should also be 5.3 repeating times taller than the stick. So that's 5.3 repeating times 3, which is a height of 16 meters. So regardless of which way you look at this, you should get 16 meters for either of your proportions for option 1 or 16 meters for option 2. Another similar method to number 2 is, instead of comparing shadow to shadow, you can also compare that the stick's height is twice as long as the stick's shadow. So 1.5 times 2 equals 3, so 8 times 2 is 16. In this case, that one might be a little easier just because you can do that one without a calculator. Regardless, the answer is 16. Go ahead and give these problems a try to make sure that you are understanding the idea of creating those similar triangles If you're not an artist, don't feel like you have to draw these items to make them actually look like a basketball hoop or a radio tower. You can just go ahead and kind of sketch out a height and a shadow. In this case, you can see that the shadow is actually longer than the height. That would be either earlier in the morning or later in the afternoon when the sun is lower in the sky. So you have 12 and 18 for your basketball hoop. And then we know that your radio tower shadows is 120 feet for this first one. And for the second one, we have to watch out because we see a tree that has a 12-foot shadow. And then we have Billy, who's 4 feet tall, but it says his shadow is 18 inches. So we have to either change Billy's height to inches and the tree's height to inches, or we can change Billy's shadow to feet. So we're going to change 18 inches to 1.5 feet by dividing by 12. Then when you solve this problem, you should get that the tree is 32 feet tall. To solve this challenge, you can also use a proportion. The tricky part here is that X is only representing this part of the figure. This is a large triangle with a smaller triangle inside it. If it helps for you to separate them and draw them as two separate triangles, do that. The smaller triangle is 10 and 6. The larger triangle is 9, and it's X plus 10. The whole thing is X plus 10. So when you're going to solve your proportion here, you have to keep in mind that this is not just X, it's X plus 10 more.